Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Under the quiet spell of night, when the last ember of daylight has faded and the sky has become a deep and endless canvas of stars, the forest begins to breathe in a way that most of us never notice. The air feels cooler, softer, as if it has been filtered through velvet, and each leaf on every branch seems to hold a secret. Moonlight spills through the canopy in scattered silver threads, touching the edges of leaves, tracing the outline of sleeping branches, and pooling in faint glimmers upon the forest floor. This is the hour when the trees, which spent all day drinking sunlight and exhaling life-giving oxygen, change their rhythm. During the day, the green world above hums with photosynthesis, a quiet, invisible magic powered by light. But at night, in the absence of the sun, trees turn inward. They inhale the oxygen they help create and exhale carbon dioxide, reversing the breath that fuels our daylight hours. It is a shift so gentle, so that only the most patient observer might sense it. If you stand perfectly still, you might imagine you feel the cool exhalation of carbon-rich air curling around your ankles, moving like an unseen tide between the trunks. This hidden breath is not a sign of weakness or rest, but of balance, a rhythm older than humanity itself. Plants, like us, live on the tightrope between energy creation and energy use. In daylight, they gather, store and build using photons to split water, freeing electrons to dance along the pathways of life. At night, the energy stored as sugars fuels the quiet work of repair, growth, and preparation for another day's light. Each cell in each leaf, each root hair curled deep into the soil, is still busy, still alive, still whispering in the slow language of molecules. In the stillness, enzymes hum like distant machinery. Mitochondria in plant cells burn sugars for fuel, and water creeps upward through xylem tubes under the steady pull of cohesion. Even in darkness, a tree is not asleep in the way an animal rests. It is more like a night watchman, performing a different set of duties under a different kind of sky. The moon, though too faint to drive photosynthesis in most plants, still plays its part. Some scientists have found that certain leaves tilt ever so slightly toward its light, their photoreceptors sensing its presence, even when the human eye barely perceives its glow. This faint silver radiation may influence the opening and closing of stomata, the microscopic pores that stud the undersides of leaves. By day, these pores swing wide to drink in carbon dioxide and release water vapor. By night, many close to conserve moisture, but in some species, especially in the tropics, they remain slightly open, allowing a slow exchange with the atmosphere. Here in the moonlit forest, that exchange continues like a whispered conversation between plant and air, imperceptible to most creatures, yet vital to the tree's metabolism. It is in this exchange, in this gentle movement of gases under the silver sky, that the forest takes its hidden breath. Roots join in the nocturnal rhythm, drawing water and dissolved nutrients from the soil, feeding them upward toward the leaves. This movement is not driven by the sun's warmth, but by the osmotic pull of minerals and the steady push of root pressure. Imagine the roots as a slow, patient pump, drawing sustenance from the earth grain by grain, ion by ion. Around them, a bustling underground world stirs. Fungi stretching filaments in search of sugars, bacteria breaking down organic matter, earthworms shifting soil to make way for air and water. Many of these organisms depend on the tree's nighttime respiration, for as roots breathe, they exhale carbon dioxide into the surrounding soil, changing its chemistry and feeding the underground web of life. In this way, the forest's hidden breath sustains both what grows above and what thrives below. The air within the forest at night is different from the air of open fields. It is heavier, infused with the scent of damp leaves, humus, and the faint musk of moss-covered bark. You can almost taste the life suspended in it. The microscopic particles of pollen, spores, and decomposing matter drifting gently in the stillness. Each exhalation of the trees adds to this invisible brew, carrying the signatures of countless species, each contributing its own chemistry to the nocturnal air. If you could bottle the breath of a midnight forest, you would capture a layered perfume, green and woody, earthy and cool, tinged with the metallic sweetness of sap and the faint tang of decaying leaves. This is the breath that wraps around you as you walk between the trunks, the breath that has been cycling through leaf and sky, root and soil for millions of years. The science of this hidden respiration is as intricate as it is elegant. During the day, photosynthesis in chloroplasts captures light energy to split water molecules, releasing oxygen and creating glucose. At night, chloroplasts rest, and mitochondria, the same kind of organelles that power animal cells, take over. They break down glucose in a series of steps known as cellular respiration, to release stored energy in the form of ATP. In doing so, they consume oxygen and release carbon dioxide just as humans do. The balance between these two processes determines whether a plant is a net producer or consumer of oxygen over a given time. In the grand scale of the Earth's atmosphere, photosynthesis overwhelmingly dominates, but on the intimate scale of a single night in a single forest, the balance tips the other way, if only briefly. Some might wonder why this nocturnal breath is worth noticing. After all, the oxygen produced by plants during the day far exceeds what they consume at night. But to ignore it is to miss a piece of the larger rhythm, the in and out, the give and take that defines all living systems. The forest breath mirrors our own. Inhale and exhale, energy gathered and spent, light absorbed and darkness endured. It is also a reminder that life does not pause simply because the sun has set. In the cool hours between dusk and dawn, the forest is alive in ways that daytime cannot reveal. Bats skim between the trunks in search of moths, owls listen for the faint rustle of prey, and somewhere in the undergrowth a frog calls into the moonlight. Each of these creatures exhales carbon dioxide into the same air the trees are breathing, completing the cycle in miniature. You can almost hear the breath if you listen with your imagination. It is not the rush of wind or the rustle of leaves, but a deeper, slower rhythm, as if the entire forest is drawing from a single lung. In this imagined sound there is comfort, for it tells us we are part of something older and steadier than ourselves. The breath of the trees at night has been flowing since before humans walked the earth, since before the first mammals stirred under the moon. It will continue long after we are gone, a constant exchange between life and atmosphere that keeps the world turning in balance. Now imagine standing in a clearing where the moonlight is strong enough to cast shadows, and the air is still except for the occasional sigh of a night breeze. The trees around you are engaged in their quiet respiration, their leaves catching what little light the moon offers, their roots drinking deeply from the soil, their cells working silently in the dark. Above you, the stars burn cold and ancient, their light travelling for years before it meets your eyes. The same light falls on the canopy, reminding the forest of the vast universe beyond its borders. Somewhere in this interplay of light and shadow, air and leaf, lies a truth about life, that it is not only the blazing energy of day that sustains us, but also the cool, steady work of night. This is the hidden breath of the forest, not a secret in the sense of being concealed, but in the sense of being easily overlooked. To notice it is to slow down, to match your own breathing to that of the trees, to feel the gentle pull of the earth beneath your feet and the tender push of the atmosphere around your skin. It is to remember that every inhalation you take has passed through countless leaves, and every exhalation you release will feed something green. The moonlit respiration of trees is a lesson in humility, in patience, and in the quiet beauty of cycles that do not need to be seen to be real. It is here every night, waiting for those who are willing to listen with more than their ears. Deeper into the night, the forest's hidden breath becomes not just a fact of biology, but a story written across every branch, leaf and root. The gentle exchange of gases, invisible to the eye, is tied to ancient patterns shaped by the pull of the moon, the drift of clouds, and the slow, patient turning of the earth. Scientists studying the nocturnal respiration of trees have discovered that this is not a simple, uniform process. It shifts with temperature, with the richness of the soil, with the age of the tree and the history it carries in its rings. In warm, humid nights, respiration is more intense as cells work faster, enzymes moving with ease through the pathways of energy release. On colder nights, the process is slow, conserving resources, stretching each molecule of sugar into a longer breath. The forest, in its way, adjusts itself to the weather, as we might pull a blanket closer or loosen it in the heat. This adaptability is one of the secrets of survival, and in trees, it is expressed not in movement but in chemistry, a quiet modulation of the rate at which life flows. Roots hidden beneath the soil are part of this rhythm. Though they rest in darkness at all times, they too have a day and night cycle. By night, their activity often increases as the sugars produced in the day flow downward from the leaves through the phloem, feeding the underground network. This journey of sugars, known as translocation, is one of the most remarkable feats in plant physiology, a movement not driven by pumps or muscles but by the careful balance of pressure and solute concentration. As these sugars reach the roots, they fuel growth, repair, and the strengthening of the tree's hold in the earth. They also feed the mycorrhizal fungi entwined with the root tips, which in turn help the tree absorb water and minerals more efficiently. This partnership is so intimate that the breath of the tree at night cannot be considered without also imagining the breath of the fungi, the bacteria, and the tiny creatures that share its underground world. Above ground, leaves rest, yet not completely. Their stomata, those tiny openings, act like gates deciding how much to let in and out. While most close tightly to conserve water in the absence of sunlight, some remain partially open to allow continued exchange with the atmosphere. The pattern varies from species to species. In rainforests, where humidity is high, more stomata may stay open, allowing respiration without risking dehydration. In deserts, nearly all close by nightfall, keeping precious moisture locked inside. These variations are adaptations honed over countless generations, allowing each species to thrive in its chosen home. When you walk through a mixed forest under the moon, you are moving through a patchwork of different breathing patterns, each tree negotiating with the night in its own way. The moon itself has a subtle but real influence on the forest. While its light is faint compared to the sun, certain wavelengths it emits may still be perceived by plant photoreceptors. Some studies suggest that moonlight can slightly alter the opening and closing of stomata, or shift the timing of certain internal clocks, the circadian rhythms that regulate plant processes. These rhythms are precise yet flexible, allowing trees to anticipate dawn and prepare for it even before the first hint of light appears. The interplay of moonlight and darkness may also influence flowering in some species, especially those that rely on night-flying pollinators. In this way, the moonlit breath of the forest is connected not only to respiration but to reproduction, signalling to certain flowers when to open, when to release their scent into the cool air. The forest's nighttime breath is also shaped by its inhabitants. Animals contribute their own respiration, adding carbon dioxide to the mix that trees can use when photosynthesis resumes. In some cases, the presence of large populations of insects, birds or mammals can slightly enrich the local air with CO2, making the microclimate of the forest unique compared to open areas. In return, the forest's canopy traps and stabilizes the air, preventing the kind of rapid cooling that might occur in open ground. This keeps the nocturnal chemistry of the forest stable, allowing respiration to proceed in a consistent environment. It is a quiet partnership. The trees shelter the animals breathe for the trees, and both are sustained by the unseen tides of the air. Beneath the stars, the forest floor becomes a place of delicate exchanges. The carbon dioxide released by roots does not always rise straight into the air. Some of it dissolves into the water in the soil, forming carbonic acid that slowly weathers minerals, freeing nutrients for future growth. This slow process, invisible and patient, is part of the cycle that renews the fertility of the ground. It is one reason why forests, left undisturbed, can sustain themselves for centuries, recycling their own nutrients through layers of leaf litter, soil, and roots. The hidden breath of the trees is a part of this cycle, moving carbon not only into the sky, but into the very stones beneath our feet. Even the way the forest smells at night is shaped by the respiration. Volatile organic compounds, faint aromatic chemicals, are released as part of the tree's metabolic processes. Some are byproducts of respiration, others signals to insects or warnings to neighbouring plants. In the stillness, these scents can hang in the air for hours, creating the distinctive perfume of a moonlit woodland. A walk under the trees becomes not just a visual experience but an olfactory one, each inhalation carrying hints of resin, damp bark, and the faint sweetness of decaying leaves. These scents are molecules, each one a piece of the forest's invisible breath, drifting outward until they are broken down by the air or carried away by the wind. As the night deepens, temperatures often drop, and with it the rate of respiration slows. Trees, sensitive to these changes, adjust their metabolism accordingly. The enzymes that drive cellular respiration become less active and the release of carbon dioxide tapers. Yet the forest never stops breathing entirely. There is always some slow exchange, some trickle of energy moving from sugar to cell, from root to leaf. It is like a long, deep sigh, not the urgent panting of daylight growth, but the measured breathing of a living thing at rest. This constancy is part of what makes forests such steady anchors in the natural world. No matter the season, the night, or the weather, they continue their quiet cycles, each breath a small act of persistence. In this stillness, one can almost feel the forest's awareness of the coming dawn. Long before the first hint of light touches the horizon, certain processes within the trees begin to shift. The internal clocks that govern plant life start to prepare for photosynthesis, activating enzymes, opening stomata, and moving water toward the leaves. The hidden breath of night is not just an ending, but a preparation, a gathering of strength for the return of the sun. It is a reminder that even in rest, life is always leaning forward toward its next moment of growth. The more one learns about this nighttime respiration, the more it becomes a symbol for all the unseen work in the world. Just as the forest seems still but is alive with quiet processes, so too much of life's progress happens in invisible ways. Seeds germinate underground long before any green shoot appears. Rivers carve valleys slowly, carrying away grains of stone one by one. In our own lives, change often begins in the hidden hours, in the slow reshaping of thoughts and habits before anything outward is visible. The hidden breath of the forest becomes a metaphor for patience, for the understanding that the most important transformations rarely happen in the glare of daylight. If you were to lie down on the forest floor now, staring up through the branches into the moonlight, you might notice how your own breathing slows to match the rhythm around you. Inhale, and you draw in molecules that may have been in a leaf's airspace moments before. Exhale, and you release carbon dioxide that may, by dawn, be taken in by a leaf and fixed into sugar. The connection is not poetic metaphor but chemical fact. We are, quite literally, part of the same cycle, our breaths interwoven with those of the trees. Under the moon, with the air cool against your skin and the scent of the forest in your lungs, this truth feels not just scientific but deeply human, a reminder that every quiet moment is part of something vast, ancient, and beautifully alive. As the deepest hours of night give way to the slow approach of dawn, the forest's hidden breath lingers in the cool air like the last note of a song. The trees stand motionless, their branches dark silhouettes against a paling sky, yet within their cells, the quiet machinery of life continues to hum. This final stretch before morning is a time of transition, when the balance between oxygen consumption and production begins to shift once again. The forest, which has spent the night drawing in oxygen and exhaling carbon dioxide, now begins to anticipate the return of the sun, readying itself to reverse the flow. It is a subtle shift, not a sudden gasp, but a gradual reorientation of countless microscopic processes. The mitochondria, which have been the primary engines through the hours of darkness, continue their steady work, breaking down sugars, while the chloroplasts stir faintly, preparing to awaken with the light. Beneath the soil, roots continue their patient gathering, pulling water upward through the xylem. Even before dawn, this movement strengthens, ensuring that leaves will have the hydration they need for the day's photosynthesis. Alongside them, fungal filaments deliver minerals gathered through the night, tiny gifts from the soil's underground cities of life. The carbon dioxide exhaled by roots has already altered the microclimate around them, feeding the microorganisms that will, in turn, support the tree's growth in ways too intricate for the human eye to follow. Every part of the forest, from the tallest canopy leaf to the sea's smallest hair-like root tip, is engaged in this cooperative preparation. It is as if the entire woodland takes a deep collective breath in readiness for the sunrise. In these moments, the air is at its purest and most balanced, rich with the last whispers of the night's respiration and the faintest hints of the oxygen surge that is about to begin. If you stand still, you might notice how the forest feels suspended between two worlds, the shadowed realm of moonlit breathing and the luminous expanse of daylighter production. The horizon begins to shift in colour, a slow bleed of grey into pale blue, then into the soft gold that announces the sun's imminent arrival. The light at this stage is delicate, gentle enough that the leaves seem to cradle it, holding it close as though reluctant to let it spill too quickly into the day. The influence of the moon lingers even now. Though its pale disk fades in the strengthening light, its role in guiding the forest's rhythm through the night remains embedded in the tree's internal clock. Certain leaves that had tilted slightly toward its glow now adjust toward the east, aligning with the sun's path. Stomata, which have been either tightly closed or partially open depending on the species, begin to respond to the faint rise in temperature and the shift in spectral light. Slowly their microscopic mouths open wider, preparing to draw in the carbon dioxide that will fuel the next cycle of growth. Respiration does not stop, it never does, but it is soon outpaced by the flood of oxygen produced by photosynthesis. This change is not instantaneous. For a brief period after sunrise, both respiration and photosynthesis occur alongside one another in near balance, like two voices speaking at the same time in different tones. During this overlap, the forest is both inhaling and exhaling, a duality that speaks to the complexity of life's processes. It is in this fragile balance that we can see the continuity between night and day, the way one flows into the other without a hard dividing line. The hidden breath of night is not erased by the day but carried forward, transformed into something new by the touch of light. Animals too sense the change. Birds begin to stir, their early calls weaving through the trees like strands of thread in a vast tapestry of sound. Their breathing adds to the forest's carbon dioxide for a short while longer, before the sunlight floods in and the trees begin to consume it more rapidly. Insects that rested in the cool darkness now stretch their wings in the growing warmth, each movement a tiny spark of energy that traces back to the sugars stored in plant tissues, sugars created during previous days, powered by sunlight captured in the green pigments of leaves. Even the predators of the night, the owls and bats, are drawn into this moment of change, retreating to their hidden shelters while the forest shifts to the tempo of daylight. By mid-morning, the hidden breath has receded into memory, replaced by the vibrant inhalations of photosynthesis. The carbon dioxide exhaled by the forest through the night has been reclaimed, bound into sugars that will feed its cells and sustain its growth. Yet the night's respiration is not wasted. It has nourished the soil, maintained the life of every cell, and kept the forest's cycles in motion. Without it, the day's work could not begin, for respiration is not a pause in life, but its constant foundation. In the grand dance of energy, it is the step that allows all others to follow. From a scientific perspective, this nightly rhythm is a reminder that life is a continuous process, one that adapts to the absence or presence of light but never stops. From a poetic perspective, it is a lesson in constancy, a quiet truth that even in darkness there is movement, purpose, and preparation for what is to come. The trees do not despair when the sun departs, nor do they waste the hours of night. They simply change their focus. shifting from creation to maintenance, from building to sustaining until the light returns. This balance, this seamless adjustment, is one of the reasons forests endure for centuries, weathering storms, droughts, and the slow passage of time. And so, when you next walk under the moonlit canopy, remember that you are witnessing more than a silent stand of trees. You are in the presence of a living, breathing community, engaged in a cycle as old as the earth itself. Every breath you take is part of that cycle, every exhalation a contribution to the endless exchange between life and atmosphere. Whether by the glow of the moon or the blaze of the sun, this cycle continues without fail, binding us to the trees in a bond both physical and profound. The hidden breath of the forest at night is not something most will ever measure or see, but it can be felt in the stillness, tasted in the cool air, and imagined in the slow unseen dance of molecules from leaf to sky. It is an act of connection, a reminder that even in the absence of light, life not only persists but thrives in its own quiet way. As the day grows brighter and the memory of the night fades, the breath remains, folded into the forest's endless rhythm, a rhythm that waits, patient and unbroken, for the moon to rise again. There are nights when the forest seems to lean closer to the sky, as if listening for a message carried across the gulf of space. The air is so still that each leaf seems to be holding its breath, and yet there is movement, not of wind or animals, but of the invisible exchanges between earth and heavens. Trees, rooted in the soil yet reaching toward the stars, live between these two realms. In daylight, their dialogue is with the sun, but at night, their conversation changes, becoming softer, more delicate, spoken in the language of faint light and cooler air. The stars offer no warmth to the leaves, yet they mark the turning of the earth, their positions shifting with the hours and seasons. In this celestial clockwork, trees find cues to time their growth, to open and close their tiny pores, to send signals along their hidden vascular highways. This is the silent exchange, a nightly communion between the green world and the glittering sky, too subtle for the human ear, but written into the life of every branch. While the sun fuels photosynthesis, the stars seem to fuel a different kind of awareness. Many plants possess circadian rhythms, internal clocks that anticipate changes between light and darkness, and these clocks are sensitive not only to the presence of sunlight but to the absence of it. In the hours of darkness, when photosynthesis rests, the cells of a tree engage in other work, repairing tissues, transporting bogort from leaves to roots, regulating the storage and release of energy. These tasks, though internal, are not entirely cut off from the world above. Photoreceptors in the leaves can sense even the dimmest light, moonlight, starlight, and this faint illumination can help guide the timing of these processes. Just as the stars have guided human navigation for millennia, they may, in a different way, help plants keep track of the great cycles that define their lives. In the stillness of a moonless night, starlight is the only illumination that touches the canopy. It is faint beyond human imagining, yet to a leaf's light-sensitive pigments, even a photon matters. Some researchers believe that such low-level light could subtly influence the behavior of stomata, or help maintain the calibration of a plant's internal clock, ensuring that it stays synchronized with the 24-hour rhythm of the Earth's rotation. In tropical forests, where nights are nearly equal in length throughout the year, this steady cue helps anchor the predictable pulse of life. In temperate regions, where nights stretch and shrink with the seasons, the stars mark the changes, offering a faint but constant map of the shifting year. The exchange is not just a matter of light, but also of atmosphere. Every night, trees release carbon dioxide into the air, and every night the cool air of the canopy rises and falls in gentle waves. Temperature differences between the forest floor and the upper branches cause slow currents of air to drift upward and downward, mixing the exhalations of the trees with the greater breath of the planet. In return, the sky offers its own contribution: meteor dust, invisible to us, drifting down through the atmosphere, carrying trace element and like iron and magnesium that will eventually settle on leaves and soil. Over centuries, this cosmic dust adds to the nutrient pool from which forests grow, making the exchange between trees and stars not only poetic but tangible. Beneath this canopy, unseen by most, is an ocean of soundless communication. Trees send chemical signals through the air, releasing volatile compounds that can travel from leaf to leaf, from tree to tree. Some of these signals are responses to stress, others to changes in temperature or humidity, changes that on clear nights can be tied to the loss of heat to the open sky. When a warm day is followed by a clear, cold night, heat escapes quickly upward, radiating into the star-filled emptiness. Trees respond to this cooling, adjusting their metabolism, shifting the balance between conserving water and releasing it through respiration. This reaction, though driven by earthly physics, is part of the same dialogue that ties the forest to the cosmos. Roots, too, participate in this conversation in their own way. The nightly cooling of the soil's surface can create tiny pressure differences within the tree's water columns, subtly influencing the upward movement of fluids. In some species, these changes are enough to shift the patterns of nutrient transport, allowing the tree to prepare for the coming day. Underground, mycorrhizal networks respond as well, altering their exchange of sugars and minerals in response to changes in root activity. This whole system, from canopy to root tip, is aware, not conscious in the way we are, but tuned to the environment with a sensitivity honed over millions of years. Standing in such a forest at night, one might be tempted to think nothing is happening. The branches do not sway, the leaves do not flutter, the animals are hushed. Yet every molecule of air between the trunks is part of an intricate dance moving between the earth and the sky. Starlight glances off the glossy surfaces of leaves, disappearing into the pigments that once drank the sun. Wisps of scent, undetectable to human senses, drift upward and outward, blending with the exhalations of the forest and mingling with the atmosphere that envelops us all. The stars, silent in their vastness, shine down upon this exchange, indifferent yet constant, their light having travelled for years or centuries before touching a leaf. In the great scale of the universe, the nightly respiration of trees is almost nothing, a tiny alteration in the air of a single planet. Yet in the scale of life on Earth, it is everything. It is the pulse that sustains ecosystems, the movement that keeps soil fertile, the exchange that links the smallest root hair to the outermost edge of the galaxy's light. This is the silent exchange, the giving and receiving that happens without voice, without gesture, without noise, yet binds the living and the distant in a single continuous cycle. In its quiet way, it tells us that connection does not always require words, and that the most important conversations are often the ones we cannot hear. As the night deepens, the forest's exchange with the stars becomes more intimate, woven from threads of light, air and time. The canopy, now fully immersed in darkness, no longer receives the faint blush of sunset, and yet it is never without illumination. Starlight, though unimaginably weak compared to the sun, scatters across the leaves in a million soft points, each photon carrying a history measured in years, decades or millennia. These tiny messengers arrive from distant suns, their journey ending on the thin skin of a leaf, where pigments and photoreceptors still register their presence. The response is not one of immediate action, as in daylight, but of subtle reinforcement, like the way a whisper can sustain a memory. In this way, trees maintain their circadian rhythm, sensing not just the binary switch of light and dark, but the nuanced shifts in intensity that mark the difference between a cloudy night and one crowded with stars. The air between the leaves is part of this dialogue too. Throughout the night, trees exhale carbon dioxide in a slow, steady stream. This exhalation changes the chemistry of the air closest to the canopy, creating a microclimate distinct from the open sky above. The warm breath of the trees mixes with cooler air sinking from higher branches, causing delicate currents to move invisibly in the dark. If you could see these movements, they would look like shimmering ribbons flowing upward and outward, carrying molecules into the wider atmosphere. In return, the forest receives particles drifting from space, fragments of meteoroids, microscopic dust rich in minerals like iron and silicon, which settle onto leaves and soil. Over years, these cosmic traces become part of the forest's chemistry, a physical link between the stars and the trees that depend on the Earth's nutrients to live. The trees are not passive in this process. They adjust their respiration in response to temperature, humidity, and even the stillness of the air. On clear, calm nights, when heat escapes quickly to the open sky, respiration can slow as enzymes respond to the cooler temperatures, conserving energy. On warmer nights, activity increases, sugars breaking down more rapidly to fuel growth and repair. These adjustments are part of a sophisticated internal regulation, one that integrates cues from both the ground and the heavens. Even without conscious thought, a tree knows when the night is long and cold or short and warm, and it shifts its breathing accordingly. This capacity to read the night's conditions is essential to survival, especially in regions where frost or drought can arrive unexpectedly. Chemical signals join this silent exchange, travelling invisibly through the forest air. Some compounds, like isoprene and terpenes, are released as byproducts of plant metabolism. Others are deliberate messages, warnings sent to neighbouring trees when leaves are damaged by insects, or calls to attract pollinators that work in darkness. On certain nights, particularly during flowering, the forest is filled with scents that humans may barely notice, but that moths, bats, and other nocturnal creatures can detect from great distances. These scents are part of the exchange with the stars as well, for they rely on the stillness and coolness of night air to carry them farther than the turbulence of day allows. The stars, while silent, shape these conditions by their role in controlling the cooling of the Earth's surface. The clearer the sky, the more efficiently heat escapes, and the more stable the scent pathways become. Underground, another layer of conversation unfolds. Roots continue to respire, releasing carbon dioxide into the soil. This CO2 alters the pH of the surrounding earth, influencing the solubility of minerals. Mycorrhizal fungi tightly bound to the roots respond to these changes by adjusting their exchange of nutrients, passing phosphorus, nitrogen, and trace elements into the tree in return for sugars. This cycle is linked to the rhythms above. The rate at which sugars arrive in the roots is influenced by the day's photosynthesis and the night's respiration. The timing is precise. Too rapid a delivery and the roots cannot process it efficiently. Too slow and growth suffers. The stars, by governing the length of night and the cooling of the air, indirectly influence these subterranean patterns, a reminder that the forest's link to the sky is both visible and invisible. Some researchers speculate that the presence or absence of moonlight during the star's watch changes the nature of the exchange. On moonless nights, the absence of strong illumination allows the forest to cool more rapidly, intensifying the downward flow of cold air and altering respiration rates. On nights when the moon is full, the additional light may stimulate certain photoreceptors enough to slightly shift stomatal behavior or delay the onset of complete metabolic slowdown. These effects are small, yet over centuries, even subtle differences can shape the evolutionary path of species, favouring those best able to adapt to the lunar stellar cycle. Thus, the stars do not simply shine above the forest, they, along with the moon, participate in the long shaping of its life. The star's role in the forest rhythms also extends to the timing of reproduction. Many plants time their flowering and seed release to environmental cues that include the length of night and the pattern of moonlight and starlight. In tropical forests, certain species bloom on precise nights of the lunar cycle, ensuring that pollinators arrive when flowers are open and scents are strongest. In temperate zones, the gradual change in night length as the Earth moves around the Sun is tracked not only by the fading light of dusk, but by the changing position of the stars. While this is not conscious recognition, it is an inherited sensitivity, the product of generations that flourished by aligning their cycles with the heavens. If you were to lie on the forest floor and gaze upward during such a night, you would see the black shapes of branches crisscrossing the star-speckled sky. The air would carry the faint scent of leaves and soil, laced with compounds your senses barely register, but which tell a detailed story to the creatures that belong to this place. Above you, starlight would drift through gaps in the canopy, touching bark, moss, and the edges of leaves that sway only with the smallest movements of air. In that moment, you might feel the truth of the silent exchange, that the trees are not simply part of the earth, but participants in a greater system that stretches from the ground beneath your hand to the furthest visible light in the cosmos. The stars will keep their place in the sky long after the trees you see have fallen and been replaced, but in every breath the forest takes, there is a connection to that permanence. The oxygen you inhale now may have been part of a tree's exhalation under a star-filled night decades ago. The carbon you exhale tonight may rise into the air and by tomorrow be fixed into the wood of a young sapling. This movement is endless, and the stars are its silent witnesses, shining down on a cycle they neither start nor stop, yet one that seems, in their presence, eternal. In the last hours before dawn, the forest's exchange with the stars reaches its quiet conclusion. The canopy, once bathed in the cool clarity of starlight, now feels the first faint touch of the approaching day. The eastern horizon carries a subtle paleness, barely perceptible, yet enough for the most sensitive leaves to begin their shift toward morning. For the trees, this is a moment of gentle transition, a turning from the long inward breath of night toward the outward flow of daylight. Respiration, which has dominated the hours of darkness, will soon be overtaken by the oxygen-rich surge of photosynthesis. But the change is not abrupt. it comes as a gradual blending, a soft handover, where the last whispers of the stars are still present even as the first warmth of the sun begins to stir. During these final hours, the air above the canopy remains cool and dense, holding the carbon dioxide exhaled by countless leaves and roots through the night. This reservoir of carbon is part of what the trees will draw upon in the early minutes of daylight when photosynthesis begins in earnest. The stars, still visible overhead, seem to watch as the forest prepares itself for this transformation. It is an exchange that has no pause, no moment when life truly stops to rest. Even as one process slows, another quickens, ensuring the continuity of energy flow. This seamlessness is what gives the forest its endurance. There is no wasted moment, no idle silence in the dance between earth and sky. The roots remain deeply engaged in their own work, their nocturnal respiration still releasing carbon dioxide into the soil. This gas seeps upward, joining the mix in the air above, while also dissolving into the moisture that surrounds soil particles. There, it plays a part in the slow chemical weathering of minerals, releasing nutrients that will nourish the trees in months or years to come. This means that even the breath of a root at night is part of a chain that may stretch far into the future. By the time these nutrients reach a leaf, the starlight under which the root first released its carbon will be long gone, replaced by other seasons, other skies. The forest's exchange with the stars, then, is not only a nightly act, but a contribution to cycles measured in decades or centuries. Insects and nocturnal animals also sense the nearing end of night. Moths complete their last visits to nectar-rich flowers, carrying pollen between blooms before the day's predators awaken. Bats return to their roosts, their breathing slowing as they enter rest, each exhalation still feeding the forest's carbon pool. The calls of owls fade into the distance, replaced by the first tentative notes of songbirds. This shift in sound is mirrored by a shift in the chemical atmosphere. Scents released for nocturnal pollination begin to diminish, while compounds more associated with daytime metabolism start to rise. For the trees, these changes are signals as clear as light, telling them that the night's dialogue with the stars is nearly over. Yet even in these moments, the stars' influence is not gone. Their positions in the sky serve as markers for the season, guiding the forest's deeper rhythms. In temperate zones, the slow drift of constellations across the night informs the timing of flowering, leaf drop and dormancy. In the tropics, where night length is more constant, the stars still mark cycles of rainfall, migration and reproduction, their patterns woven into the ecological memory of the place. The forest does not consciously see these patterns, but it carries their imprint in its genetic programming, shaped by thousands of generations that thrived under their guidance. When the first true light of dawn touches the canopy, it arrives as a gentle wash rather than a sudden blaze. Chloroplasts in the leaves awaken, their pigments ready to capture photons after a night of dormancy. Stomata, which through the night have been partly closed in many species to conserve water, now open wider, preparing to draw in the carbon dioxide that has been gathering in the still air. Within minutes, the balance of gases shifts. Oxygen begins to pour into the air in quantities far greater than during the night, and carbon dioxide levels start to fall. The hidden breath of the night becomes the visible work of the day as the forest turns its face fully toward the sun. For those who witness it, this transition feels like the resolution of a long, slow symphony. The quiet notes of night, the faint scents, the cool stillness, the almost imperceptible movement of air, give way to the brighter sounds and warmer currents of morning. Yet the night's exchange with the stars is not forgotten. It remains as a kind of foundation, a reminder that the forest's vitality depends as much on its nocturnal processes as on its daylight production. Without the steady respiration of night, the rapid activity of day could not be sustained. Without the cool clarity of starlight and the calm air it fosters, the delicate balances of temperature and moisture would be harder to maintain. The stars will fade in the brightening sky, their light overpowered by the sun, but their role in the forest life will not end. They will return the next night, and the cycle will begin again. Respiration in darkness, subtle adjustments to light and temperature, the exchange of gases and minerals, the quiet shaping of growth. This repetition is not monotony, it is stability. In a world of constant change, the forest's dialogue with the stars is one of the few patterns that has endured for as long as there have been leaves to turn toward the light. And so, as day fully takes hold, the memory of the night lingers in the forest's chemistry, in the cooled soil, in the replenished reservoirs of nutrients and energy. The silent exchange has been completed, but it has also been renewed, set in motion once more by the inevitability of the next sunset. It is a reminder that life's most essential connections often happen beyond the reach of our senses, in the spaces where stillness and motion coexist, where the smallest movements sustain the largest patterns. The trees, the stars, and the space between them will meet again in a matter of hours to continue their quiet, endless conversation. Beneath the surface of the forest, hidden from the silver gaze of the moon, an entire world stirs quietly in the dark. Roots extend in every direction, weaving through the soil like a vast, intricate web. They are unseen, yet they're the lifeblood of the trees above, drawing water and nutrients from the earth with steady persistence. While the canopy's leaves are the forest's eyes and lungs during the day, the roots are its hands and heart at night. When the sun sets and photosynthesis rests, the flow of life does not stop. Instead, it shifts downward. Sugars made in the daylight begin their journey from the leaves to the roots through the phloem, a journey powered not by pumps, but by the subtle pull of concentration gradients and pressure differences. This is when the underground currents begin to move most freely, carrying the energy of the day deep into the earth. The moonlight above does not directly reach these hidden chambers, yet its influence is still felt. Roots respond to cycles of moisture and temperature that are shaped by the night sky. On clear nights, when heat escapes quickly into space, the upper layers of soil cool, prompting roots to adjust their activity. In warmer, more humid nights, respiration within the roots quickens, breaking down sugars to release energy needed for growth, repair, and the maintenance of their vast network. This respiration releases carbon dioxide into the soil, where it dissolves into water and begins the slow process of weathering minerals, unlocking elements like potassium, calcium, and magnesium. These nutrients will later be drawn back up into the tree, woven into new leaves and branches. Thus, even in the absence of sunlight, the roots are busy preparing for the future. In this underground world, the soil is far from still. Tiny channels carved by earthworms and insects allow air and water to move between particles, creating a labyrinth of microhabitats. Mycorrhizal fungi, those delicate thread-like partners of the roots, extend even farther than the roots themselves, reaching into spaces too small for roots to enter. In exchange for sugars from the tree, these fungi deliver phosphorus, nitrogen, and other minerals. At night, this exchange can intensify as the steady flow of sugars from the leaves provides the fungi with abundant energy to expand their network. The moon's cycles, with their gravitational pull influencing tides and groundwater, may even play a role in subtly shifting the moisture levels that roots and fungi share. Water moves upward from the roots even at night, though more slowly than during the day. This process, driven by root pressure, can be strong enough in some plants to push water to the tips of leaves, where it forms tiny droplets known as guttation. In the quiet hours before dawn, these droplets can glisten in the moonlight, a visible trace of the invisible currents within the plant. While small in volume, this upward push helps maintain hydration in the leaves, ensuring that the tree is ready for photosynthesis as soon as daylight returns. It also keeps the pathways of the xylem primed, preventing the formation of air pockets that could disrupt the flow of water when demand increases with the rising sun. The soil itself holds the memory of the day. Heat absorbed during sunlight hours radiates back slowly into the roots, influencing the rates of chemical reactions within their cells. Cooler nights slow enzyme activity, stretching the energy reserves over longer periods, while warmer nights accelerate growth and nutrient uptake. This delicate balance is part of the reason why plants from different climates have evolved distinct nighttime strategies. In tropical forests, where nights are warm and humid, root activity remains high throughout the hours of darkness. In temperate forests, roots may slow their metabolism in cooler conditions, conserving resources for the following day. Beneath all of this, in layers of soil that never see the light, are the deeper roots, tapping into ancient reserves of water stored far below the surface. These deep roots are less affected by nightly temperature changes, but still participate in the cycles of nutrient transport. In times of drought, they become the tree's lifeline, drawing from water that may have fallen as rain years ago. The slow, deliberate pull from these depths is a reminder of how trees integrate time into their survival strategies, using both immediate and long-term resources in harmony. Nighttime is also when many roots grow. While growth above ground may pause without the sun's energy, the roots use the stored sugars of the day to extend their reach, exploring new patches of soil, wrapping around stones, and slipping into the cracks between particles. This growth is not random. Roots are guided by gradients of moisture, nutrients, and even chemical signals from other plants. In some forests, roots from different trees meet and fuse, forming grafts that allow them to share resources directly. Through such connections, one tree's nighttime breath and nourishment can support another, linking individuals into a collective life beneath the moonlit canopy. Above this hidden network, the forest may seem quiet and still. The leaves glimmer faintly under the stars. The trunks stand like dark pillars, and the air is filled with the soft scent of earth. But beneath your feet, an entire world is alive with movement. Not the swift motion of animals, but the slow, powerful currents of water, sugars, and minerals. These currents, invisible to the human eye, are as vital to the forest's survival as the green glow of photosynthesis. They are the heartbeat of the trees, pulsing steadily in the dark, keeping the forest alive until the light returns. If you could listen closely enough, you might imagine hearing this heartbeat. Not a sound in the usual sense, but a sense of pressure and flow, a faint pulse that comes from the countless microscopic events happening within each root cell. It is a reminder that life's energy is not confined to the moments when the sun is shining. In the soil, in the dark, under the gaze of the moon, the forest continues to live, to work, to prepare. This is the secret current of nighttime life, unseen yet unceasing, flowing quietly beneath the world we walk upon. The deeper into the night we go, the more the underground world reveals its quiet complexity. Roots, though hidden, are not isolated. They are part of a living web that stretches far beyond the boundaries of any single tree. The sugars moving down from the canopy continue to flow, feeding the roots' respiration and fueling the growth of new tips. These growing points are covered in delicate root hairs, each one increasing the surface area for absorbing water and nutrients. Under the microscope, they look like fine threads extending into the tiny spaces between soil particles, wrapping around grains of sand and specks of organic matter. Here, in the microcosm of soil, the exchange of life is constant. Minerals dissolve into water, water flows into roots, and the carbon dioxide exhaled by the roots changes the chemistry around them, making more nutrients available. It is a self-sustaining cycle, built on the collaboration between plant and earth. The fungi that live alongside the roots are not just helpers, they are partners in a deep and ancient alliance. Mycorrhizal fungi extend hyphae, hair-thin filaments, far into the soil, far beyond where roots can reach on their own. These hyphae transport minerals and water back to the roots, and in return they receive sugars from the tree. This relationship has existed for hundreds of millions of years, shaping the evolution of forests long before humans appeared. At night, when the canopy above is still and dark, the underground exchange continues with even greater importance. The steady supply of sugars from the day's photosynthesis fuels the fungi's search for resources, allowing them to explore new territory, find fresh nutrient sources, and strengthen the network that connects trees to one another. Through this network, signals can travel, chemical messages that may warn of pests, coordinate flowering, or even share resources between trees in need. In some forests, roots from different trees physically connect, grafting together so that water and nutrients can flow between them. These connections can cross species boundaries, allowing, for example, a tall, healthy tree to feed a smaller, shaded one nearby. This sharing is especially important at night, when transpiration has slowed and the pressures within the water columns of the trees are more balanced. Without the pull of evaporation from the leaves, the flow of resources is freer to move laterally, nourishing those in need. In this way, the nighttime currents beneath the soil are not just about individual survival, but about the collective health of the forest community. The moon, though it cannot shine through layers of soil, influences these hidden processes indirectly. Its gravitational pull affects groundwater just as it does the tides in the ocean. In certain soils and at specific depths, this can create subtle fluctuations in water availability, rhythms that roots and microbes alike may respond to. Over the course of the lunar cycle, these patterns may shift, changing the pace at which roots absorb water and transport it upward. Some researchers suspect that root growth and nutrient uptake may even show a faint lunar rhythm, syncing with these gravitational tides in ways we're only beginning to understand. Temperature also plays a key role in the secret life of roots at night. Soil retains heat from the day, releasing it slowly as the air above cools. This gentle warmth helps maintain the fluidity of water and the speed of chemical reactions within the roots. In colder climates, this heat release is crucial, allowing roots to keep functioning through the night without freezing. In warmer regions, it can prolong high metabolic rates, supporting rapid nutrient processing and growth. The balance is delicate. too much warmth at night can increase respiration to the point of depleting stored sugars, while too much cooling can slow activity so much that the plant falls behind in growth. Trees have adapted to these conditions over centuries, fine-tuning their nighttime metabolism to match the character of their environment. Beneath the surface, animals add their own influence. Burrowing insects, earthworms, and small mammals constantly reshape the soil, opening new channels for water and air to reach the roots. Their movements mix organic matter into the mineral soil, providing a steady supply of nutrients for roots to tap into. At night, many of these creatures are more active, and the disturbances they create help maintain the soil's structure. In turn, the carbon dioxide released by root respiration feeds the microbial life that breaks down organic material, completing a loop that ties together plants, fungi, and animals in a shared underground economy. The deeper roots, those that tap into ancient water reserves, are perhaps the most constant players in this nocturnal cycle. They respond less to the fluctuations of temperature and moisture at the surface and more to the slow changes in the water table far below. During the night, when demand from the canopy is lower, these roots can store water within the plant's tissues, creating a buffer for the hotter, drier hours to come. This stored water can be essential in regions where days are long and evaporation is intense. Even in wetter climates, this nightly storage adds resilience, allowing trees to maintain a steady flow of water to their leaves under sudden changes in weather. If we could see this underground world in its entirety, it would look like a vast glowing network, roots branching and rebranching, fungi stretching out in fine threads, water and sugars moving along invisible pathways, and countless tiny organisms working in between. This is the true foundation of the forest life, a place where the energy captured from starlight-filtered days is invested in the infrastructure that supports growth, survival, and reproduction. And yet, for all its importance, it remains largely hidden, its rhythms unfolding in silence beneath our feet. Walking through a moonlit forest, you might never guess that such a world exists just below you, alive and busy in the stillness. The roots will never call out to announce their work, and the soil will never rise up to reveal its currents. But the health of every leaf, the strength of every trunk, and the fragrance of every flower depends on these nightly exchanges. It is here in the dark that the forest invests in its future, building and repairing the systems that will face the demands of another day. Without this hidden labour, the green abundance of daylight would wither, and the song of the forest would fall silent. In the final hours before dawn, the world beneath the forest floor continues its unbroken rhythm, carrying the last of the night's energy through roots and soil. Above, the canopy is still cloaked in darkness, but the faintest grey has begun to touch the horizon, and though no sunlight has yet reached the leaves, the roots are already responding. The steady downward flow of sugars that began at sunset now begins to slow, shifting towards balance as the tree prepares to restart its upward surge of photosynthesis. Yet the work of the night is not done. In the cool soil, respiration continues, each root cell drawing in oxygen and releasing carbon dioxide, each exchange contributing to the unseen chemistry that keeps the forest alive. These last hours are a time of quiet consolidation. The water drawn in during the night is stored in the xylem, ready to meet the day's demand. Nutrients gathered from the soil by the combined work of roots and fungi are moved into position for transport to the growing tips above. The carbon dioxide released by respiration accumulates in the soil air spaces, enriching the underground atmosphere for the microbes that will continue their work through the day. This steady preparation is like the final step in a long, deliberate breath, a deep inhalation before the exhalation of light-driven growth. The deep roots, those tapping the hidden reservoirs far below, maintain their slow and constant pull. They are unaffected by the slight changes in temperature that ripple through the upper soil layers as dawn approaches. Instead, they continue to gather water that has been filtered through layers of rock and sediment, water that may have fallen as rain years, even decades ago. This deep reserve is a kind of memory for the tree, a connection to past seasons stored in liquid form, waiting to be drawn upon in times of need. By morning, this water will be part of the flow that rises through the trunk, feeding the first surge of transpiration as the day warms. Around the finer roots, life is still active. Earthworms make their last nocturnal burrows before retreating from the heat of day. Fungal threads continue their slow expansion, reaching into untouched pockets of soil, binding particles together and releasing enzymes that dissolve locked nutrients. Even the smallest shifts in pH caused by root respiration will influence which minerals become available, shaping the tree's diet for the coming day. This delicate interplay, roots breathing, fungi feeding, microbes breaking down organic matter, is a choreography repeated night after night, season after season. The moon, if it still lingers in the sky, casts a pale light across the forest floor, but its influence underground is more about rhythm than illumination. The lunar cycle subtly shapes groundwater movement, and in certain soils, these tides in moisture affect the ease with which roots can draw in water. Over time, these patterns may leave their mark on the growth rings of trees, tiny variations that tell of wetter nights or drier ones, of high tides in the subterranean rivers, or low tides when moisture was scarce. The roots, though blind to the moon, carry its signature in their very structure. As the first hint of morning light filters through the canopy, signals move through the plant to prepare for the shift in metabolism. Stomata in the leaves, still mostly closed from the night, begin to open slightly, ready to draw in carbon dioxide. This change above triggers adjustments below. The flow of water upward strengthens, pressure within the roots changes, and the direction of nutrient transport begins to reverse. The night's downward currents give way to the upward pull of the day. The underground world feels this shift not as a sudden jolt, but as a gentle rebalancing, like a tide turning toward shore. The air within the soil changes as well. Oxygen drawn in by roots is replenished more quickly now, as the warmth of the coming day increases diffusion rates. Carbon dioxide released during the night begins to rise toward the surface, where it will join the air above and be drawn back into the leaves in the hours ahead. This recycling is part of the forest's constant economy, in which nothing is wasted and every molecule finds its way back into the cycle in time. For the roots, the end of night is not an end to activity, but the beginning of a new phase. The sugars they have stored will be used to sustain growth through the day. The moisture they have drawn in will flow upward, cooling leaves and carrying nutrients. The alliances they maintain with fungi and microbes will continue, shifting their balance to suit the new conditions. In this way, the underground world remains in harmony with the canopy above, each responding to the other's needs in a seamless loop of cause and effect. If we could shrink ourselves to the scale of a root hair in these moments, we would see water molecules slipping through cell membranes, ions moving through protein channels, and sugars flowing through the phloem in streams too small for the naked eye to imagine. We would feel the pressure within the cells, the subtle stretching of root tips as they grow into new spaces, the quiet efficiency with which every part performs its task. we would sense the presence of the whole, the tree above, the soil around, the forest beyond, all connected by the steady, patient work taking place in the dark. By the time the first true beams of sunlight touch the forest floor, the transition is complete. The roots settle into their daytime rhythm, slower in their sugar intake, more focused on delivering water upward to the leaves. Yet the work of the night remains within the tree, embodied in the minerals now ready to feed new growth, in the water waiting to rise, in the strengthened bonds between root and fungus. It is a reminder that the forest's vitality is not only born of sunlight, but also of the deep, hidden labour that takes place out of sight. Beneath the moon, in the cool soil, the roots have prepared the foundation for another day of life, and when night comes again, the secret currents will flow once more, unbroken and eternal. When the moon lifts itself above the horizon and spills its silver light over the forest, it is easy to believe its reach ends where its glow fades. Yet the moon's influence runs deeper than sight, deeper even than the canopy, reaching into the hidden waters that move through the soil and roots. Just as the moon pulls at the vast oceans, shaping their tides, it also tugs at the water held in the land. These lunar tides are so subtle that a human could never feel them beneath their feet, yet the forest knows. The pull shifts the distribution of groundwater, drawing it slightly upward during certain phases, pressing it deeper during others. Trees, with roots like patient fingers spread through layers of soil, respond to this slow, invisible breathing of the earth, drinking in the dark with a rhythm that matches the sky above. Even in the absence of sun, water moves upward within a tree. During the day, most of this flow is driven by transpiration, the pull created when water evaporates from leaves, but at night, with stomata mostly closed, a different force takes over. Root pressure, built from the movement of minerals into the xylem, draws water from the soil and pushes it toward the canopy. This upward movement is faint compared to the daytime surge, but it is steady, and during certain nights, when the moon's pull aligns with the forest's own cycles, it can increase. On these nights, water from deep layers rises more readily, reaching roots that might otherwise draw less. For a tree, this means replenishing its reserves, hydrating its tissues, and preparing for the coming day's demands. The lunar cycle does not only affect how much water moves, but also when. In some studies, researchers have noticed fluctuations in stem diameter and sap flow that align with moon phases, suggesting that trees subtly expand and contract in response to these gravitational changes. This is not a conscious act, but a mechanical one, a quiet adjustment in the tissues that hold and transport water. In the forest, such changes are synchronous. Countless trees shifting together in tiny increments, their trunks swelling by fractions of a millimeter as they take in more water during certain lunar phases. If we could watch the forest in time-lapse over weeks, these expansions and contractions would appear like the gentle inhalations and exhalations of a living lung. The soil plays its part in this dark drinking. Water moves through it under the influence of gravity, capillary action, and the moon's pull, travelling through pores and channels shaped by roots, rocks, and the passage of countless small creatures. During wetter lunar phases, when groundwater is drawn slightly upward, the topsoil can hold more moisture, making it easier for shallow roots to absorb it. This is especially important in dry seasons, when every extra drop can mean the difference between steady growth and stress. In deeper soils, the same pull can shift the balance between water stored in large pores and that locked in the finer spaces between particles, altering how readily it can be taken up by roots. In tropical forests where nights are warm and evaporation from leaves can continue even after sunset, the lunar pull can subtly influence transpiration as well. On bright, humid nights, certain plants keep their stomata partially open, allowing a small exchange of gases and a continued draw of water from the roots. This gentle flow may synchronize with lunar tides, enhancing the movement of water upward. In temperate zones, where nights are cooler and stomata close more tightly, the moon's influence is felt more in the soil and roots than in the leaves, but the effect is still present, guiding the quiet ascent of water toward the canopy. There is a poetry to the way the moon shapes the forest's thirst. It is not a force that overwhelms or dictates, but one that suggests and nudges, like a distant conductor guiding an orchestra through a passage that might otherwise go unnoticed. The trees respond not with grand gestures, but with minute changes in flow, pressure, and expansion, changes that over time matter. A slightly fuller reservoir of water in the tissues at dawn can mean longer hours of photosynthesis before stress sets in. A deeper reach of moisture during a dry spell can sustain a seedling that might otherwise wilt. In this way, the lunar tides become part of the forest's survival strategy, written not in the broad strokes of weather, but in the fine print of nightly rhythms. If you were to walk through the forest on such a night, you might not see any sign of this movement. The trunks would be still, the leaves motionless, the air calm. Yet beneath your feet, in the soil and within the wood, water would be on the move. It would be slipping upward through vessels thinner than a hair, pulled by gradients of pressure and aided by the moon's unseen hand. Around the roots, the moisture would be shifting, flowing into the cells that line the xylem, being pushed upward to feed branches and twigs that will greet the morning with a ready supply. This movement would be silent and invisible, but as real as the glint of moonlight on a still pond. The trees do not drink the dark in the way animals drink water from a stream. Their drinking is constant, unhurried, and guided by forces both terrestrial and celestial. The night offers them a time to replenish without the demands of daytime evaporation, to take in what the soil offers and store it deep within their tissues. And on nights when the moon's pull is aligned with their needs, they drink more deeply, drawing from sources that might otherwise remain untouched. This is the lunar gift, a slow, patient tide that nourishes without fanfare, a reminder that even the faintest forces can shape the life of a forest over time. By the time dawn approaches, the extra water drawn in during these nights will be moving toward the leaves, ready to be used in photosynthesis. The moon will fade from the sky, its work for now complete, and the forest will turn its attention to the sun, but the memory of the night's drinking will remain in every hydrated cell, in the fullness of the leaves, in the steadiness of the day's transpiration. The lunar tides will continue, night after night, phase after phase, an unending exchange between sky and earth, connecting the light of the moon to the life of the forest in ways both measurable and mysterious. As the moon continues its slow path across the night sky, the forest adjusts its drinking to match the subtle pulses in the earth's water. The lunar pull is not uniform. It waxes and wanes with the phases, and the trees seem to move in step with it. On nights near the full moon, when its gravitational influence is at its peak, the flow of water through the roots and into the xylem can be ever so slightly greater. Sensitive instruments have shown tiny changes in trunk diameter during these nights, as if the trees are swelling with the added intake. This is not swelling in the human sense, but the microscopic expansion of water-filled cells as their tissues become more hydrated. The forest feels it in a way we cannot, a quiet fullness that prepares every leaf and bud for the day ahead. The water itself carries more than just hydration. It brings dissolved minerals and nutrients gathered from the soil, drawn up from depths that vary with the moon's cycle. In certain phases, the pull can encourage deeper moisture to move toward the surface layers of soil, replenishing zones that may have been dry for weeks. Shallow roots seize the opportunity, absorbing this fresh supply and passing it upward through the network of vessels. Deep roots, on the other hand, respond by increasing their own uptake, tapping reservoirs that lie beyond the reach of evaporation and rainfall. The result is a complex choreography in which different parts of the root system are drinking from different layers of the earth, their combined flow creating a steady rise of water toward the canopy. Around the roots, the soil itself changes character under the moon's influence. As water shifts through its pores and channels, it alters the tension holding it in place. In sandy soils, the movement may be swift, offering quick but temporary hydration. In clay-rich soils, the change is slower, but the increased water content can make nutrients more soluble, allowing roots and their fungal partners to absorb them more easily. Mycorrhizal fungi sensitive to these changes adjust their growth accordingly, sending hyphae towards zones that have just become wetter, ensuring that no opportunity for resource gathering is missed. These tiny explorations happen invisibly beneath our feet, but they are as responsive to lunar tides as the ocean's waves. The moon's role in the forest's drinking extends upward as well. On clear nights when the moonlight is bright, some plants alter their stomatal behavior, keeping these microscopic pores partially open even in the absence of the sun. This allows a small but steady transpiration stream to continue, pulling water upward from the roots and maintaining flow through the plant's vascular system. Such movement helps prevent stagnation in the xylem, ensuring that the pathways for water remain clear of air bubbles that could block flow. On these nights, the moon acts not only as a gravitational force but also as a gentle guide for plant physiology, sustaining a connection between soil and sky through the thin columns of water rising inside the trunks. In the deepest hours of night, when the moon is high and the air is still, the forest seems at its most receptive to this hidden tide. The absence of wind allows the humidity to build, reducing the pull of evaporation from leaves and giving the roots time to replenish the water lost earlier in the day. This is when the lunar-assisted drinking is most efficient, a time when the forces below ground and above are in balance, allowing trees to restore themselves without strain. Each droplet taken in is a piece of the next day's survival, stored in the cells and vessels until the first warmth of morning calls it upward in force. Animals too are part of this nocturnal water cycle. Burrowing creatures open new paths for water to seep into the soil, while others feed on roots or fungi, subtly shifting the underground structure. Their activity often peaks under certain moon phases, whether guided by light, tides, or internal rhythms, and these disturbances influence how and where water moves through the soil. In turn, the trees respond to these micro-changes, redirecting their fine roots toward pockets of moisture or areas newly enriched by decaying organic matter. The lunar tide, in this way, does not act alone. It interacts with countless other forces, from the digging of a beetle to the fall of a single leaf. The gravitational pull that drives the ocean's tides may seem too vast and slow to matter to a single tree, yet over millions of years, forests have adapted to live with it. The timing of seed germination, the pace of root growth, and even the movement of sap can carry traces of lunar rhythm. These patterns are not rigid rules but gentle tendencies, like a river's current shaping the path of a drifting leaf. By aligning themselves with these subtle forces, trees make the most of the resources available to them, drinking when the earth offers more and conserving when it offers less. If you could see inside a tree during one of these nights, you would find a quiet but dynamic world. Water molecules would be sliding upward along cell walls, drawn through microscopic pits between xylem vessels. Minerals would be passing into the stream, carried toward the leaves where they will be built into new tissues. Sugars stored in the trunk would be moving toward the roots to fuel their continued growth. And within the roots themselves, living cells would be breathing, taking in oxygen from the soil and releasing carbon dioxide, feeding the underground life that supports them. The moon's pull may not control these processes outright, but it shapes the conditions in which they happen, making certain nights more generous than others. By the time the moon begins to dip toward the horizon, the trees have taken what they can from its influence. Their tissues are replenished, their reservoirs topped up, their delicate balance of water and minerals restored. The forest will hold this quiet gift until the sun returns, when the demands of light-driven growth will once again pull on every drop stored through the night. And as the moon continues its endless cycle, the forest will drink again, in rhythms too slow for us to feel, but perfectly attuned to the turning of the earth and sky. In the final stretch before dawn, the moon's influence on the forest's drinking begins to ease, but the memory of its pull still lingers in the soil and within the trees themselves. The trunks, which have subtly expanded during the night as water filled their vessels, hold this quiet fullness as if savouring it before the demands of daylight begin. The deep roots remain steady, drawing from the ancient reserves far beneath the surface, while the shallow roots finish their last, gentle intake from the topsoil, which is still cool and moist from the lunar tide. Every part of the root system is now aligned toward one purpose: to hold on to this water long enough to feed the great upward surge that will begin when the sun rises. The air is still dense with the night's humidity, a blanket that slows the escape of moisture from leaves and soil alike. This lingering dampness gives the trees a moment of grace, a buffer between the end of their nocturnal replenishment and the start of daytime loss. In these moments, the lunar tide feels less like a pull and more like a presence, a quiet ally that has ensured the forest begins its day well prepared. Even as the moon lowers toward the horizon, its work continues invisibly. The water it helped lift toward the roots is still moving cell by cell, vessel by vessel, toward every twig and bud. Beneath the soil, the fungal partners of the trees make their final nighttime exchanges. Nutrients collected through the night, phosphorus, potassium, magnesium, are handed over to the roots in return for sugars that flowed down from the leaves hours earlier. This trade, though constant throughout the day, often peaks during the night when the flow of sugars is at its strongest and the fungi have more energy to extend their reach. The moon's subtle adjustment of soil moisture can make these exchanges more efficient, allowing hyphae to slip into new microspaces and find fresh pockets of minerals. By the time morning arrives, these nutrients will be making their way upward, ready to be built into new cells as the day's light returns. Some nights, particularly those with a bright full moon, see a slightly different balance. The extra light prompts certain plants to keep their stomata partially open longer into the night, maintaining a trickle of transpiration. This small upward pull of water works alongside the lunar tide, creating a steady movement that keeps the xylem active. On such nights, the forest may awaken with a more hydrated canopy, its leaves heaviest with water and better able to withstand the heat of the day ahead. On darker nights near the new moon, the focus shifts more towards storage and conservation, with the trees sealing in their reserves until daylight demands begin. The animals of the forest also feel the change as night leans toward day. Nocturnal creatures retreat to their shelters, their movements slowing, their foraging done. In doing so, they leave the soil less disturbed, allowing the last movements of water to settle into their final places before the sun stirs evaporation into motion. Small mammals and insects that have loosened soil during their nighttime activity inadvertently improve water infiltration for the next cycle, preparing the ground for future lunar tides. The forest is an intricate system in which every action, even the smallest, ripples outward to affect the way water moves and is stored. As the eastern sky lightens, the gravitational influence of the moon remains, but it becomes less noticeable against the greater forces of sunlight and evaporation. The trees are already shifting their metabolism, chloroplasts awakening in anticipation of photosynthesis. The water gathered overnight will now be put to work, cooling leaves, carrying nutrients, and driving the chemical reactions that build sugars from carbon dioxide and light. In the balance between night's slow replenishment and day's rapid use, the lunar tides have provided a crucial head start, filling the forest's reserves while the world was still. This nightly gift, though subtle, is cumulative. Over weeks and months, the extra hydration on certain lunar phases can mean healthier growth, stronger resistance to drought, and more successful reproduction. In regions where the climate is unpredictable, this quiet advantage can be the difference between survival and decline. For seedlings just establishing their roots, the lunar pull can help them tap moisture before their young systems are stressed by the demands of day. For ancient trees with massive crowns to support, it can provide just enough reserve to sustain them through dry spells, keeping the great canopy green and vital. By the time the first direct rays of sunlight pierce the canopy, the moon is low and fading, its silver replaced by the gold of morning. The forest seems unchanged to a casual observer. The same trees, the same stillness, the same damp scent of leaves and soil. Yet within every trunk and branch is the imprint of the night's work. The water lifted under the moon's influence is already on its way to fueling the life of the new day. The lunar tides have done their work quietly without witness, leaving no sound or spectacle, only the simple fact of a forest ready to grow. And so the cycle continues. Night after night, phase after phase, the moon's pull moves water through the hidden veins of the earth, and the trees drink in the dark. It is a process so ancient that it predates the forests themselves, a force that shaped the movement of water long before roots evolved to follow it. Even when we cannot feel it, it is there, a soft, steady hand guiding the flow of life from soil to sky. And when night comes again, the forest will once more turn toward the moon, ready to receive its silent silver tide.